posting LLMs in Ollama. If you've not watched the Deepseek video, it's a progression of that. So instead of just Deepseek, we're actually going to have 4 LLMs running, so we can compare them and stuff like that. So I cover it. If you want to do it just on your PC or Mac, if you load up LM Studio and then just load in various models, that'll work, and it'll let you play with it on your desktop nice and easily. Obviously, we're after a career in AI, so we're going to try and access a API, and we're going to try and do it either on a virtual machine on your laptop, so you can do it for free, or on a Raspberry Pi. Both work. So this is just the virtual machine, very much like the Deepseek video. Still pretty much the same Ollama.service file, and basically we build up the VM. We'll show you the script, or on a Raspberry Pi, install an Ubuntu server, and then just follow the steps in the file, and it's all good. So these are the lines again. So we're making a 4 gig VM on my MacBook Air, with two virtual CPUs. So we're using a quarter of the capacity of my MacBook Air just to run this experiment, and we've been through this file before, but basically the last 2 lines are the important ones. That's the command to install Ollama, sorry, and we're making a file called the Llama service, which is pretty much identical. So here's the Ollama service file. The only change from default is that environment Ollama host 0000. That means Ollama is going to answer to every network interface on the machine, so every NIC, so that you can host it remotely, because we're going to call in from the MacBook Air itself to the virtual machine on the MacBook Air. And the only line that's different from the Deepseek are the fact that we're running, as well as Deepseek, we're running Llama, Qwen, and Gemma. So we're 4 different LLMs. Because we've only given 4 gig to the machine, we've used the smallest one, so the 1.5 billion or the 1 billion size model. So these are typically the smaller size of the LLMs. We're running 4 of them. The results may vary if you use a bigger LLM, but then again, you need more hardware. So so what we're going to do is we're just going to ask them all, why is the sky blue? But we're going to do it in an API way. So curl's the same as a web browser, effectively. It's a command line. So the line in blue is the address, which is the Ollama port on the network interface, and we're just going to ask it why the sky is blue, and we'll ask Deepseek, then Llama, then Qwen, then Gemma. When we do this, it takes about 10 seconds to come back with a response. Obviously, we can give it a beefier machine for faster results, or going the GPU world or whatever. But this is just running a small CPU, ticking along. 10 seconds is fine. It answers. It gives us the answer. You can see it says the sky's blue to a phenomenon called Rayleigh scattering, and then there's lots of other numbers that are relevant or not so relevant at this point in time. So both what we send is called a JSON packet, and what returns is a JSON packet, and this makes it easier to see. So this is in Visual Studio Code, and you can see the model that's responding, the time it's responding. The actual response is what we care about. I know it scrolled off the screen just now, but we'll come back to it in a second. And then there's various other things like context and eval count and stuff like that. So when we use it as a programming, we can use these to extract and do further things. In reality, what we're going to do is to get higher quality response in a future video, we'll work out how to improve the quality response. But here is the response from 3 of them. Oh, sorry, I've got a typo. It should be Qwen, not Owen. But in blue, you can see they all reference Rayleigh scattering. In red, they actually talk about altitude, which is quite interesting. I didn't realise the altitude changed the things. And Gemma's, the stuff in green is unique to Gemma. So it's quite interesting. They've come back with similar but very different answers covering stuff. I don't know if they must probably have the same source material. I think if we use, rather than the smaller size module, I think a bigger model will give us maybe better answers. But that was just to let you have a wee oversee that they're all similar. And that's it. Thank you very much.